Hello, everybody. My name is Tyler Hart, and I'm thrilled to welcome you to a special edition of KETIV Virtual Academy. I say it's special because today we're adopting a fun new format where we will get a peek behind the scenes into how multiple engineers solve the same problem. Our very own Maddie Onesco is providing commentary on how application engineers at KETIV chose to approach the same problem with an Inventor in their own different ways. It's a perfect demonstration of how there are many different ways to come to the same conclusion, and that's what makes our job so fun. So Maddie and members of her team will be standing by to answer questions in the Q&A as we move along today, and we'll also have time for questions at the end of the presentation. Also, all of these sessions are recorded and available for distribution on ketiv.com or on our YouTube channel, so go check them out and share them. There's a lot more great content like this. So without further ado, let's get started.
Hi guys, so today we're going to see how 4 different engineers will approach the same model in Inventor. So I first wanted to introduce everybody to give you an idea of where we all came from and what kind of modeling experience we have. So first off, my name is Maddie. I am an application engineer on the support and training team here at KETIV. I graduated about a year ago from the Pennsylvania State University with a degree in biomedical engineering. I'm an Autodesk certified professional in Inventor for mechanical design, as well as an Autodesk certified instructor. I joined KETIV right after graduating, so I have no industry experience, but I have had some of the best teachers and resources available to help me learn Inventor over the past year. I will be one of the 4 designers today, as well as the commentator, to walk you guys through the steps that each person took. Next up, we will see Nicole. She is the manager of KETIV's support and training team. She's been an Inventor instructor since Inventor R1. She has been a mechanical civil designer since the 80s and has been with KETIV since 1998. Next up, we have Mario Soblavaro. He has 25 years of background in commercial automation design. He specialized in capital equipment, automated end tooling, and automated assembly lines. And lastly, we have Marco Trinidad, who graduated from San Jose State University with a degree in mechanical engineering design. He's an application engineer on the support team and is an instructor for Inventor and Fusion 360. He joined KETIV right out of college, like me, about 2 years ago. So the 4 of us were all tasked with modeling a mounting base for an air compressor's motor and pump inside of Inventor. But half of us took a top-down modeling approach, while the other half were given a fully dimensioned drawing to go off of. So the first 2 engineers will be Nicole and Mario. They were given an almost completed assembly and asked to design the mounting base for the motor and pump to attach onto the air compressor tank. So let's take a look at that. So here's the assembly they were given. You can see below the motor and pump there that the mounting base is missing. So this is exactly what they were given, and they weren't really given any other instructions or guidance. They were just asked to create a mounting base for this specific assembly. And then on the other hand, we had myself and Marco. We were given a drawing of the exact missing mount from that same assembly and asked to model it according to the given dimensions. So we'll take a look at that drawing. Here we have a fully dimensioned drawing of the missing mounting base. So first up is Nicole. She will be creating a mounting base for the pump and motor to sit on top of using a top-down modeling approach. She did not have a lot of information or design parameters to go off of, so she'll be using adaptive design. She first starts out by creating her own workspace where she has some components that are turned off and out of the way, then creating a new part using a sheet metal template. And she's going to be using the bottom of the motor as the base of her sketch and starting the sketch on the XZ plane. She's going to start out with a big rectangle and no constraints yet. So you'll see with an unconstrained adaptive design, Nicole will be using the assembly to help her create the size of this mount. She's then creating a sheet metal face, and she will be adding some flanges to the ends as well. Then she changes her sheet metal thickness to what she thinks fits the model best, 5 millimeters. She's going to make her face adaptive here, which makes the corresponding sketch and sheet metal part adaptive as well. She can now jump up to the top level assembly and move around and constrain her mounting base as needed. So we'll see as she does that. So after applying some constraints to get her base in place, she's going back to the part level, creating a sketch and projecting the necessary geometry from that hose to allow her to create corresponding cutouts. So here she notices that her mount is running into a hose. So she jumped back up to the top level assembly and adjusts that offset of her mate constraint to make it so they don't interfere with each other. So now we're back in the mounting base, and she's going to add a cut with a corner round in feature mode. And rather than projecting the geometry and using that to create the drill holes for the motor and pump to mount onto, she's going to be using bolted connection. So she does this to speed things up and just make things easier for herself. We'll watch now as she does that. So the nice thing here is once she does that first bolted connection, she can then use that same bolt template for the other 3 holes. And then we'll see she repeats the similar process for the pump.
So on top of the drilled holes, I just added some slots there so that the motor had the freedom to move.
Now she's cutting out those slots. Okay, so now Nicole's going to show how she extends those flanges to actually reach down to the tank's face. So to do this, she's going to go to her mounting base and bring the whole air compressor, or at least the tank, inside that mounting base model. So you'll see she's going to roll back her end of model to before she actually created the flange. And then she's going to copy the entire tank object into the model as a surface. And now that that's there, she can drag down the end of the model to after the flange was created to bring that flange back in. And then she's going to create a 3D sketch and project the curve of the flange to the tank surface. So now she can create a plane that's parallel to the top of the mount at that point. And now she can extrude it to that plane, allowing the flange to reach all the way down to the tank like we want.
Now that we saw how Nicole approached her design being given the whole assembly, I'm going to have Marco jump in and show how he would approach the design just being given this fully dimensioned drawing of the mount.
So the first thing I'm going to do is create a new sheet metal part. And I'm going to set my sheet metal default. It is a different thickness, so I'm going to change this thickness to match up the part, which is 0.118. So click OK. And then I'm going to start with my sketch. I'm going to click in here. And I'm going to change my view so that it matches up with what I want. Create my rectangle. I am going to do from the center because I know later on I might want to use some of the origin planes for my features, or for symmetry. So I usually, if I can, which in this case I can, I'm going to use my origin plane. So now that I have my basic cutout, I'm going to go ahead and create my face. Up is fine, and then I can add in the flanges on each side. Now I do want to make sure that they line up the right way. The measurement for the height of it is this line, so I want to make sure that this edge lines up with this inner edge. Change my dimension on that. Alright, now I can start my new sketch on the top face here. And I'll do this one for all of the cutouts that I need. So I'm going to just project some geometry here, and that's just so I can use it for my reference. For the circular cutouts, I'm not going to cut them out here. I'm just going to create points to where I want them to be. So that way when I use the whole feature, I can just use these points. So I'm just going to create some constraints so that I can position them. And then create a construction line diagonal because the measurement is diagonal. Okay, so the first thing I'm going to do is add my dimension. I have to switch this to diagonal 5.85. And then I can start to go in here and add some of my other dimensions, 4.8 from the top, 1.97. And then I can drag this around, make sure things aren't moving. I can see that this is moving a little bit, so let me see what is constrained. And let me add one more here. So I want to make this midpoint line up with the midpoint of the edge, and that should be my last one that I need to add. Now if I try to click and drag, it doesn't move around. Next up, I'll make my slot over here, and this one's 4.88 and 2.27. Oh, I don't want that to be construction. Let me do that one more time. Okay, and then once again I'll create a constraint so that it lines up with the center, and then I can add in my slot. Do my slot here, dimension, and then I do want this to be a diameter, so change that, and that is going to be 0.33. Add in some more dimensions, 8.21. Alright, so I do want these centers to line up, so I'm going to go ahead and add another constraint here. Right. So then I think I have most of everything so far. Just need to add one more dimension in here. Okay. And let me just check one last thing here. Okay, the last one, this one needs to be 1.014. Okay. Now exit out of that, and the next thing I can actually do is create some mirrored geometry. So I'm going to grab this, and my mirror line, let's be the center. Let me actually add one in here. Okay, so I'm just going to create a mirror across here. Click apply, click done, and now I have my two slots. Alright, and then I think I can finish that one out and create my cuts. So for now, I am just going to cut these and then share this sketch so that I can use it for my hole cutouts. So now I do have these points all along here, and I can go into the hole, and I'm just going to select this one. And let me see what kind of hole I want. I just want a simple hole with 4.33 diameter. And I'm just going to apply this one. And then these other four have, let's see, 0.49. And click OK. Now I can hide my sketch. And I have all my cutouts there. So next up, I want to create my cutouts on the side. So there are some slits on each side, but they are symmetric, so I only need to create one. But I do see that one of the dimensions is based off of a chamfer it has on the edges, so the next thing I'll do is actually to chamfer here. Go in here, select my 4 edges, and that's going to be 1.8. And now I can go in and create my sketch. Once again, just going to project this and start with the circle. Position doesn't really matter right away, just because I end up positioning it with my dimensions. So I'm going to go ahead and go in here. This one is a radius, so this one's 0.17. And it has a height of 1.38. Let's create that. That was the dimension that I needed the chamfer for, 5.1. So now I have my slope right here. Exit that and create the cut. Oh, no, not that. Cut this one. Like this. Like that. Let me edit my sketch. Edit this. One line in here. I think that's what was going on. Cut. I'll try this one more time. So let's create my circle. And I just want to project this one line. This one is a 0.34. This 0.38. And from H to H, that's 5.18. Okay, so I do have my cutout there. And now I actually want to mirror this cutout. So I'm just going to go there. And since I did make it symmetrical, I can mirror across here. And I think, let's click clay. And then mirror those across the other way as well. And then the last thing is I have some holes on the back side of it. So I want to make sure I get those as well. So I'm going to go back over here and create a sketch with a few holes. I'm just going to project the bottom line here and create 3 points. This one lines up with the center. Let me see, 1.38. And then this is just going to match that one. And the last one is And then now I can create my holes. I actually have a couple more points I need to add in here. One more construction line just to make sure these are centered as well. And let me see how far apart these are. One. Okay. So I'm going to create my holes once again, this time. Just want to go to this back surface. They're not going through everything. So let me go ahead and add some dimensions in here, 0.79. Share the sketch. And keep on adding my holes. So this one. This one's going to be 0.55. Now one thing I don't have, and I think you can kind of see it here, is the bend rule that is exactly for the one that I'm creating. So you can see it kind of goes up into here, but that would depend on the sheet metal defaults, which I don't have that for now, but just thought I'd make a note of that. And then these two are 0.46. Now these are threaded, so you can create a tapped hole here. I don't have the exact measurements for that, but just a note that you'll see it kind of shows up there cosmetically. So now that I finished up, I can hide that, and that should be my finished part.
So next we will watch as Mario, similarly to Nicole, takes a top-down modeling approach, having been given this assembly you see here. He will walk us through how he went about modeling the mounting base. Mario is creating a new sheet metal part. Choosing the bottom of the motor as the base of the model. He then changes his sheet metal default and now he'll go ahead and start his sketch on the plain underside of the motor's bracket. He projects the geometry of the brackets and the holes, creating a rectangle which will become the face of his sheet metal mounting base. After creating a sheet metal face with that rectangle, he's adding some flanges to the ends. He overshoots the distance so it intersects the tank. And we'll see, in order to make his flanges actually meet up with the outside of the tank there, he is going to create a sketch and project the geometry of the tank.
Now this allows him to go in and extrude away the unnecessary material to make his flanges tangent to the tank. So next Mario considers where his holes will be placed for the pump and motor. He does not utilize bolted connection like Nicole. On the pump side, he creates a sketch on the surface of the bracket, projecting the hole geometry and adding the holes at the part level. And moving over to the motor here, he notes that the motor should be able to slide to allow for some tension, so he creates slots constrained to these projected geometry of the existing holes, ensuring they'll line up, and then he goes in and extrudes these slots rather than cutting them in sheet metal. And now he is going to create the holes for that mounting bracket you see on the back here. He does notice that the bracket is interfering with his mounting base, so he fixes that off screen. And now we'll watch as Mario measures the existing bolts to allow him to eventually create holes for these. And now he's going in at the part level and creating a sketch. So he decided to project the geometry of those bolts to allow him to create holes. And now he's going to create a sketch on the face of the flange. And he's using slots to create some vibration relief slots here, which Nicole nor Marco and I did not consider doing this at all. So Marco's background likely helped him out here and taught him that this would be necessary for a component like this. And he's now just extruding those out. Now he's going to jump back over and create the hole for the hose to fit through in the middle. And he's going to do that by projecting the hose geometry in a sketch and extruding that out. Now he returns to the assembly level and will be placing in the weld nuts that were originally used in this assembly. And now he's going to go in and constrain these nuts so they line up with the underside of each of the existing bolts. So now we're going to watch as Mario actually adds welds to his mounting base, which is not something the rest of us considered doing. Next, he creates a flat pattern of his mounting base. And with that, Mario is all done. And last but not least, we have myself modeling this mounting base based off of that sketch that I just showed you guys. So first I went in and I changed the sheet metal thickness based on what the sketch dimensions showed. And I started off first with just a rectangle based off the dimensions. And I like to add my features right inside of my sketch, rather than finishing the sketch and adding all of my holes and everything later, unlike Marco. So we can watch as I go ahead and add the hole for the hose in the middle, and then I'm going to add the two little mounting holes for the bolts to fit through on the right. And you can see I used my rectangle there as a guide to create the holes, allowing me to dimension it a bit easier. And then I'm going to jump over and add in the slots that we saw in the drawing. Now I'm just dimensioning it out. So in comparison to the top-down modeling that Mario and Nicole had to do, there wasn't too much extra thought that had to be put into my model here, since I just was going right off of the drawing that I was given. And now that that's done, I'm going to create the rounded rectangle that goes in between those two slots. I also use auto dimension a good bit if I notice I'm missing a dimension or two and I'm not sure where. Now I'm just adding these fillets to the rectangle. And now I'm finally done with my first sketch. I'm going to create this into a sheet metal face. And then I'll add my flanges to the ends. So next I'm adding in those corner chamfers at the specified length. Here I just measured it to make sure it was correct. We didn't have all of the dimensions, but it looked correct enough. And here I'm adding in the vibration relief slots that we just saw Mario add in. So Mario actually added 4 of these, but in the drawing we were given, it only specified to add 2, so that's what I'm doing here. Had I known with this drawing was actually 4, that there would be a pump and a motor on top of it, I might have in retrospect added in 4 different relief slots, but so once I get this our slots fully dimensioned here, I'm going to be adding in the 5 holes that we saw in the drawing. Those will be the points where the mounting base actually mounts onto the bracket of the air pressure tank. So now that those are dimensioned out, I extrude out each of those holes. And then I'm going to go in and make that a shared sketch so that I can reuse it to cut out those slots. So you can see here now I'm creating cuts for the slots. And turning off the visibility of that sketch. Then I realized in the drawing that it showed those slots on both flanges, so I am extending that over to the other side as well. And with that, my model is completed. I hope it was interesting for you guys to see how 4 different engineers with varying levels of experience came together, given 2 different sets of instructions to create that same modeling mount for an air pressure tank.
Thank you, Maddie. That was fun. We'd love to stick around and ask any questions. I'm sure you guys have ideas about how you might have done things differently. It'd be interesting to hear from anybody who has any input about ways that they would have done things. Is this interesting to you guys? Is this something you'd like to see again? I see there's quite a few people still on the session in the chat.
Thomas says yes. Nicole, Maddie, thank you so much for putting together this new format. Really cool to see all the different ways to get to kind of the same outcome, and just goes to show that there's a lot of different ways to approach it. So I personally would love to see this again in the future, and looks like the audience agrees as well. Well, if anybody has further questions, feel free to pop them in the chat or the Q&A here. Otherwise, we're always available at support@ketiv.com. We're always here on Thursdays for these types of sessions. And you can also look at a backlog of the sessions on our YouTube channel or on ketiv.com/KETIV Virtual Academy. So stick with us here, and we'll continue to put out content like this.
Thank you, guys.